Okay, we are in live, Nasser.
Okay. Good morning. Bismillahirrahmanirrahim. Assalamu alaikum. We are meeting again at the Mir Moinul Memorial Lecture Series. This is number 9. This series is conducted by our organizers participating from all over the globe. As usual, the organizers of this technical session are Nazim Ahmed, Jashimuddin, Murtuza Ahmed Chishti, Manwar Ahmed, and our Zoom video administrator, Qazi Azizur Rahman. They are doing a great job in organizing this session. This is Naz Hussain joining from Houston, Texas. This lecture series is carried out every month in honor of Mir Moinul Masood, who spent all his professional life in geological exploration in Bangladesh. This lecture series is an integral part of remembering Masood and carrying out his devotion to exploration geology that he left behind. This technical session is providing knowledge and awareness among the geoscientists in the field of exploration geology in Bangladesh. Today's lecture topic will be on clastic sequence stratigraphy, standard methodology and application to the Bengal Basin. Speaker will be Dr. Abu Said, ex-staff geologist, ConocoPhillips and Husky Energy. The second speaker will be Mr. Abid Ludi, consulting petroleum geologist. After the presentation, we will hear comments from an analysis from Mr. Abu Chaudhary, first honors batch, an ex-geophysicist living in Houston who did the groundbreaking work in sequence stratigraphy back in the early 2000s. And from Dr. Badrul Imam, Professor of Geology, Dhaka University. After that, the floor will be open for question and comments. Our moderator of today's session will be Jashimuddin, ex-geologist of Petrobangla, BAPEX, and international oil companies. Once again, thank you all for joining the session today. I now hand over to Jashimuddin. Thank you.
Welcome to all. আমরা বাংলা ও ইংরেজিতে আমরা ঠিক উভয় ভাষাটাকে আমরা ব্যবহার করব, কারণ আমাদের সঙ্গে এখানে উপস্থিত আছেন যে ডক্টর লিজ, উনি আমাদের পরম শ্রদ্ধেয় এবং বাংলাদেশে 80-র দশক থেকে বাংলাদেশের স্ট্র্যাটিগ্রাফি এবং জেনারেল জিওলজি নিয়ে কাজ করছেন। এখনো তিনি বাংলাদেশের উপর গবেষণা করছেন এবং পুস্তক লিখছেন, আমরা যতটুকু জানতে পেরেছি। আমরা অত্যন্ত আনন্দিত যে উনি বিগত দুটো সেশন থেকে উনি আমাদের এই লেকচার সিরিজে অংশগ্রহণ করছেন। তো আমরা একটা সিদ্ধান্ত নিয়েছি যে এর মধ্যে আমাদের যারা প্রথিতযশা জিওলজিস্ট এবং যারা আমাদের এই জিওলজিতে, এই দেশের জিওলজি, তেল গ্যাস উন্নয়ন এবং ভূতত্ত্ব, সাধারণ ভূতত্ত্ব, স্ট্র্যাটিগ্রাফি সবকিছুতে একটা বড় ধরনের ভূমিকা রেখেছেন এবং তাদের একটা পরিচিতি আমরা দেওয়ার চেষ্টা করব। সেটা হলো যে আমরা প্রথম শুরু করব ডক্টর হাবিবুর রহমান সাহেবকে দিয়ে, কারণ আপনারা সবাই জানেন যে বাংলাদেশে পেট্রোবাংলা জন্ম, পেট্রোলিয়াম ল ইনাক্টেড করা সবকিছুতে, তারপর এনার্জি যে সিকিউরিটি, আমরা বলবো যে 5টা গ্যাস ফিল্ড যেটা করা, এগুলি আসলে আমাদের মতুজ আহমেদ সাহেব ওনার সম্পর্কে একটু বলবেন, তারপরে আমরা মূল সেশনে যাব। আমি মুর্তজা আহমেদ ফারুক চিশতি সাহেবকে বলার অনুরোধ করছি, তার সম্পর্কে তার পরিচিতি আপনারা জানেন। তিনি এই বাখরাবাদে যোগদান করেন প্রথম, তারপর পেট্রোবাংলায় আসেন। পেট্রোবাংলায় বিভিন্ন দপ্তরে, সেটা খনিজ, প্রোডাকশন শেয়ারিং বা প্রোডাকশন শেয়ারিং এ উনি যদিও ওখানে করেননি কিন্তু পার্ট রেখেছেন। প্ল্যানিং এ ছিলেন, মধ্যপাড়ায় ছিলেন, হাইড্রোকার্বন সেলে ছিলেন। শেষ সময়ে লাস্ট সময়ে উনি বাপেক্সের এমডি হিসেবে ছিলেন। তো ওনারও এই ক্ষেত্রে বিস্তারিত অভিজ্ঞতা সঞ্চয় করেছেন এবং তিনি আমাদের প্রতিটা সেশনে আছেন অর্গানাইজিং এ, যেটা আমাদের নাজ ভাই বলেছেন যে ওনার সম্পর্কে। আমি জনাব চিশতি সাহেবকে, জনাব হাবিবুর রহমান সাহেব সম্পর্কে কিছু বলার অনুরোধ করছি।
Before you start, let me tell a little bit. We need to speak a little bit of English and give Dr. Lees some idea what is going on. Otherwise, he'll be completely in the dark if we speak all Bangla. Okay, so we welcome Dr. Lees here, and we apologize for if we miss somewhere that you are not following us. Our speaker will try to explain as much as possible in English so that you can follow.
Thank you. Thank you very much.
Chishti, going on. Chishti, you are muted.
Okay.
Okay.
সকলকে আমার সালাম। আজকের আলোচনায় আমরা আমাদের স্মরণীয় বরণীয় মধ্যে প্রথমে ডক্টর হাবিবুর রহমান সাহেবের উপরে শ্রদ্ধা জ্ঞাপন করব এবং তার সম্বন্ধে কিছু বলবো। আমাদের পরম শ্রদ্ধেয় ডক্টর হাবিবুর রহমান ছিলেন বর্ণাঢ্য জীবনের অধিকারী একজন কীর্তিমান ও কিংবদন্তিসম পুরুষ, যার কর্মময় জীবনের শেষ পর্ব স্বদেশকে উৎসর্গকৃত। তার পুরো নাম আবু ইউসুফ মোহাম্মদ হাবিবুর রহমান। পাকিস্তান ভূতাত্ত্বিক জরিপ অধিদপ্তরে তার কর্মময় জীবনের শুরু। সেখানে সঙ্গী হিসেবে পেয়েছিলেন এক ঝাঁক ভূবিজ্ঞানী, যারা স্বাধীন বাংলাদেশে ভূবিজ্ঞান প্রসারে বিশেষ ভূমিকা পালন করেছেন। মুক্তিযুদ্ধের প্রাক্কালে তিনি তেল গ্যাস খনিজ শাখাতে ঢাকায় যোগদান করেন। তার স্বদেশ প্রেম পেশাজীবন থেকে মুক্তিযুদ্ধের মাঠে নিয়ে যায়। তিনি মুজিবনগর সরকারের অধীনে যুব ক্যাম্প পরিচালনা করেন, যেখান থেকে অকুতোভয় যোদ্ধারা রণাঙ্গনে ঝাঁপিয়ে পড়েছিল। কলকাতা প্রেসিডেন্সি কলেজে অধ্যয়নকালীন সময়ে বঙ্গবন্ধুর সাথে তার পরিচয়, যার অনুপ্রেরণা এবং সান্নিধ্য ডক্টর হাবিবুর রহমানের স্বদেশ ভাবনায় বিশেষ ভূমিকা রাখে। স্বাধীনতা উত্তরকালে দেশ পুনর্গঠনে তেল গ্যাস খনিজ সম্পদ অনুসন্ধান উন্নয়নের দায়িত্বভার বঙ্গবন্ধু তার উপর অর্পণ করেন এবং তিনি ছিলেন পেট্রোবাংলার প্রথম চেয়ারম্যান। তারই সময় প্রণীত হয় পেট্রোলিয়াম আইন, যার ফলে তেল গ্যাস সম্পদের উপর জনগণের মালিকানা প্রতিষ্ঠিত হয়। স্বাধীনতার পর সমুদ্রে তেল গ্যাস অনুসন্ধানের যে পদক্ষেপ নেওয়া হয় তার প্রধান রূপকার ছিলেন তিনি। দেশের জ্বালানি নিরাপত্তা প্রতিষ্ঠার পেছনে বঙ্গবন্ধুর প্রধান সহযোগী ছিলেন তিনি। 60-এর দশকে শেল অয়েল কোম্পানি কর্তৃক আবিষ্কৃত 5টি গ্যাস ক্ষেত্র তিতাস, বাখরাবাদ, হবিগঞ্জ, রশিদপুর এবং কৈলাসটিলা ক্রয়ের জন্য বঙ্গবন্ধুর পরামর্শে তিনি বিশেষ কৌশলী ভূমিকা পালন করেন। ফলে মাত্র 18 কোটি টাকা সমমূল্যের বৈদেশিক মুদ্রা অর্থাৎ মাত্র 4.5 মিলিয়ন পাউন্ডে চুক্তি সম্পাদিত হয়, যার প্রতি কিস্তি ছিল মাত্র 66,000 পাউন্ড। এর ফলশ্রুতিতে পরবর্তী পর্যায়ে এবং বর্তমান সরকারের আমলে 9 আগস্ট পালন করা হয় জাতীয় জ্বালানি নিরাপত্তা দিবস। পরবর্তী সময়ে দেশের সম্পদ লুণ্ঠনের বিরুদ্ধে তিনি সোচ্চার ছিলেন। 1988-89 সালে সিমিটার চুক্তির বিরুদ্ধে বাংলাদেশ যুব ইউনিয়ন কর্তৃক গঠিত গণতদন্ত কমিশনকে বিভিন্ন তথ্য ও পরামর্শ প্রদান করেন। ফলে ওই অসম চুক্তি বাতিল করা হয়। এই প্রথিতযশা পুরুষ বঙ্গবন্ধু হত্যাকাণ্ডের পর খুনিদের অধীনে আর চাকরি করেননি। ডক্টর হাবিবুর রহমান 30শে নভেম্বর 1926 সালে জন্মগ্রহণ করেন এবং তিনি 11 জানুয়ারি 1991 সালে মৃত্যুবরণ করেন। আপনাদের সকলকে ধন্যবাদ।
ধন্যবাদ চিশতি। Now I'd like to request to deliver his technical on clastic sequence on stratigraphy standard methodology by Dr. Abu Yusuf. Dr. Abu Yusuf, please start your deliberation.
Assalamu alaikum. Salam and greetings to all. I will try and convey everything I can in English, since Dr. Lee is a veteran stratigrapher in Bangladesh is here, so we can get some valuable comments from him. So the topic today, we know about the clastic sequence stratigraphy, and because of the wide range of experience we have in today's audience, and some are doing intensely and intensively stratigraphy and sequence stratigraphy, and some are probably doing other fields of geology. So I'll try and follow a fine line as much as I can using the simple terminology as much as I can. So, and like all of you know, our dear Lodi Bhai will convey the second part of the presentation that would be focused mainly on Bengal Basin, and I'll be talking generalized, the evolution of methodology and what's the recent updates, basically. So there we go. And my main objective today for all of you is to convey very few points. First of all, I would like to convey what is sequence stratigraphy for all of you. For some of you, it's nothing new. And then how it should be done and why it is done. And the most important thing I want to convey, what not to. And that's something I really want to emphasize, what not to do for financial loss and for reputational loss, what we shouldn't be doing. So that's all. Just like any kids, I want to ask them, start off with the basic question: what it is, why, how, and then what not to. So, what is sequence stratigraphy? In a very simple term, it's the analysis of sedimentary basin field. That's all it's about. And now, if I go to the next level, okay, how we want to do it, basically. So basically, our intention and motivation is to subdivide this sedimentary basin field into individual sequences of deposition. So now we're talking about processes, basin-wide processes, right? And ultimately, our main objective as a stratigrapher would be to reconstruct the net preserved. Remember, we don't preserve everything that we had. So net preserved sediment, how it filled the basin and how the stratigraphy evolved through space and time. That's all about it. And this sort of a cartoon, mixed cartoon, however you want to call it, it's just for conceptual representation. It's not the exact location. So we go out on an outcrop or maybe down in the subsurface with seismic and well logs, we see layers of rocks. That's beautiful. But wouldn't it be even nice if we can subdivide them nicely into process-based sequences? And the reason we want to do that, the benefit of do that, is we want to predict the paleogeographic setting. We want to predict the reservoir. distribution, non-reservoir distribution. So before I go into go further, just a quick snapshot. Again, most of the points and concepts I'm presenting here is actually from the stratigraphic subcommission of the International Stratigraphic, those nomenclature. And Octavian Catanouy is one of the leading, he's been trying for decades actually to bring everyone together. So the whole thing started back in 50s almost. And then we went through the Galloway maximum flooding surface bounded genetic sequence stratigraphy. Then we called so-called Exxon model and Ashton-Emre's TR sequences and a number of depositional sequences. So all these were evolving. Everything was good. There was a good scientific arguments over decades, actually. And there was misunderstanding, and sometimes it was getting personal even. But the long story short, after going through all of this, our understanding just got better, which is good. And so after all of these, and by the way, I just highlighted some of the green highlighted names. So Helen Hansen and Hjelberg. Hjelberg was my direct supervisor in Norway. Helen Hansen was my exam committee member, and we had good discussion on sequence. I have learned a lot from these two gentlemen. Ashton-Emre was, for a long time, he was my co-supervisor for my PhD here in Calgary. Posamentier was a regular visitor in our lab and very nice, very humble person to talk to, and discuss about stuff. And Octavian, of course, is a very fantastic personality. So anyways, so our, after all these evolution of methodologies and the argument and discussion, now it came down to that our main objective would be to understand the process base, what's happening in the basin. I'm talking of the basinal process, process-based understanding of the stratigraphic architecture. And why we want to do it? We want to predict the reservoir, source rock, and sill facies. And another why for us oil and gas geologists, that was for stratigrapher. There is a big price involved in it. So once we reconstruct stratigraphy through space and time, we want to predict, like I said many times, these facies. And there is a beautiful study, and the study captured only the giant oil and gas fields. And there has to be, the criteria was above 500 mmBOE or 2.8 TCF. Nearly 50% of those fields since 2000, so I'm talking about 2 decades, was from stratigraphic traps and the combination traps. And here are some other graphs, presenting the same data in different way. Like you can see the Mesozoic, the huge number of the green are the stratigraphic field discovered, and these are recoverable. These are not reserve only. So these are commercial recovered reserves. And you can see the clastic, most of the clastic traps were from stratigraphic traps. Okay, not much from structural anymore. Now going into proper methodology and core concept. Again, some of this terminology will be very basic, very, very basic for a lot of you. And for some, it could be new, and for some others, anywhere in between. So the key concept, after all this discussion and evolution of this methodologies, came down to 2 key elements: accommodation and sedimentation. And by accommodation, we're talking about the basinal accommodation. And in fact, the interplay of the rate of change of basinal accommodation space and the sediment supply, they actually are the main, they fill this basin, and they sculpture the entire stratigraphy in the end of the day. And those two, as we all know, accommodation space and sediment supply, they are the results of very many factors. You start from tectonics to Milankovitch cycle, you name it. But in the end, we are talking about interplay of these two results, accommodation space and sediment supply. Now, when we talk about individual sequences, when we try and delineate these sequences, so one of the key, we observe all the data that we have, starting from seismic to core and even thin section. If you can see a paleosol and the pedogenesis in a thin section, that's your solid data to work with. So a whole range of observations from seismic to thin section, if there is evidence of stratigraphic events, you take it, we take it. So stratal stacking pattern, it's probably the essential first step, how stratigraphy evolved, okay? And when we're talking about stratal stacking pattern, again, it is essentially the interplay between accommodation rate and the sedimentation at times through time and space. And the key, I did not include the transgressive and regressive model from Ashton Embray and others. So basically the basic bounding stratal stacking patterns are regressive or transgressive. So I have included only normal regressive, forced regressive, and transgressive. And as we all know, most of us know, normal regressive, the sediments are marching towards the basin, progressing towards the basin. And the forced regression is the same thing, but the stratal pattern should be different. So the first one is, again, these are all of these materials are from SCPM site and Octavian Cataneo 2017 paper, most of it. So the forced regression is when this relative sea level or the accommodation space, we are losing. So it's dropping and the sediments were forced to progress basinward, and it started doing step by step. It's going down, down step in a way. So they are calling it forced stepping, so forward stepping in other words, and down stepping. And then we have normal regression. So we did not force, in a sense, sediments to progress, but it is progressing because of that balance in between accommodation and sedimentation. So the sedimentation was high enough relative to the accommodation, although there was a slow relative rise in the accommodation space or sea level, relative sea level. So sediments started progressing, and they call it normal regression. Again, the same thing, it's forward stepping, but it's up stepping, slowly moving up, building upward. And then we have transgression, of course. So typically here, the relative sea level rate of rise or accommodation space was fast enough, sedimentation couldn't catch up with that. So the sediments started to backstep. So everything moved landward. So these are the key stratal stacking pattern we're talking about. And these are essential elements for sequence stratigraphic analysis. Now, again, continuing on the proper methodology and core concept, we talked about system tract already. And these are essentially subdivision of a sequence, system tracks, right? And these stacking pattern, we actually, we interpret them based on, of course, the pattern itself and the stratigraphic relation to the other patterns and the bounding surfaces. What's bounding them? And then, of course, we have, these are basically sequence stratigraphically surface or significant surfaces. There are lots of surfaces in the basin. Not all of them are significant. So some of them, we all know subaerial unconformity. We know about maximum flooding surface. And there are others, they are, a correlative conformity. There are two types. I'm not going to go into detail of this. And some of them are basically relate to the, what pattern is overlain on top, the transition in between, the stratal stacking pattern. But the ideal, overview, ideal system tracks, sometimes we don't have all of them preserved. But ideal, if we have everything, this curve known to most of us, let's say this is the sea level curve. So it's dropping, it's at the lowest point, it's moving up, rising, and it's at the highest point and keep moving on and doing it. This is relative sea level curve. In other words, accommodation space. So the falling stage we already talked about. And by the way, this is from SCPM. So this axis, I'm not sure if you can read it, but towards here this is the base inward. So anything going this way is the progradation. Moving this way should be the retrogradation or backstep. Moving up is the aggradation. Moving down is degradation. Very simple curve. And this arrow is showing what is the falling stage system track. So this is related to the forced regressive stacking. So we forced sediment to move towards the basin because we dropped the base sea level, relative sea level. So this is the pattern. These top sets will march one after another one stepwise going downward towards the basin. And then the sea levels start dropping, continue dropping, and it came to its lower stand, the lowest stand within this cycle. So we call it low stand system track. It starts from here. And again, it's prograding basinward. It's a progradation, net progradation, but it's building up slowly. So what we have, these top sets or the shelf slope trajectory, they're moving up. This angle is moving up. On seismic, it's very neat to see all this, that's how I start. I look for this break, shelf slope break. And when you see these geometries doing this, you know what system track you're in. So these are slowly moving up and prograding towards basin. And then from here on, the relative sea level started rising. So in other words, our accommodation space is increasing. And like it's mentioned before, if the rate of accommodation space, the total volume of space we have is way more than the volume of sediments coming into the basin, sediments cannot catch up. So everything's going to move landward. So that's what's happening here. This is basinward, this is landward. So all these top sets or the shelf slope breaks, they're going to step backward towards the land. So this is transgressive system track. Pretty simple. And then we have high stands. So the sea level continue rising all the way to here. So relative sea level is at the high stand, if you will, and we produce our high stand system tract. And here what happens, again, it's prograding basinward. It's a slower progradation because the rate of rise of that relative sea level slows down. As it reaches here, it slows down. So when it slows down, your rate of creation of accommodation space slows down. So there's a very minor increase in accommodation space, but still it's prograding. And the top sets are, again, aggradational and progradational in a sense. So these are the basic elements: falling, marching towards basin. All of these are regressive, prograding towards basin, except for this one, transgressive. Pretty simple here. And the bounding surfaces, they are important. It's the style, the stratal pattern, and the bounded by what? Bounded by one of these surfaces. And based on that, we can identify the stratal, the system tracks. Now, one example from here, it's online is a huge resource nowadays, uninterpreted section and interpreted section. So if I can relate to the previous cartoons we just talked about, here is our forced regressive, right? So we have to have this subaerial unconformity on top and basal surface of forced regression at the base. So that's technically, this arrow just moved, sorry. So this surface is here. These are, you can see the truncation top left here and everything's moving down. Here is the raw data without interpretation. So this becomes that BSFR, and on top is your SU or subaerial unconformity. And then we move to the next one. We want to see the normal regression, which is the low stand. Remember, sea level at the lowest stand point. So the accommodation space is not increasing at a faster pace. So there we have the subaerial unconformity at the base, which is the top of the falling state. And then you have transgressive surface of the next sequence, the transgressive system tracks, the transgressive surface on top. And here is the transgressional cartoon. So below we have maximum regressive surface, which is essentially the basinal indication of the maximum regression during this normal regression stage. And on top, here is the transgression. So the end of the transgression is the maximum flooding surface near when the sea level is near its high stand. So that's what we have here, which is here. And then we have normal regression followed by that, which is the high stand system tract. Remember, high stand sea level at the highest stand, if you will, and the accommodation space, rate of creation of accommodation space slows down. So it's prograded again, high stand system tract. So this is ideal. They have all of the sequences, but you may not have all of them. It depends on how intense the next event's erosional forces, right? So sometimes you preserve some of them, sometimes you don't. So, the very, very good chance if you have a slight uplift here and local loss of accommodation space, you probably will not have this transgressive system tract here preserved. So, watch the data, and it's fun. It's actually, sequence stratigraphy is a very fun subject. So now what not to do? So we don't want to apply sequence stratigraphy technique without sound knowledge. That's very important. If I don't know something, I shouldn't try and do that. I should learn first. And then we can draw premature and misleading conclusion without thorough understanding. And that's a big mistake, because industry has lost billions of dollars by doing it. And even today they're doing it. And I myself was involved. I'm not going to name the companies. One of the company is a giant out of 5 top in the world. And this thing slipped through, $1.2 billion project. They would be crying. People would be losing job because of improper understanding of simple stratigraphy. That's all. And then sometimes you see people, we tend to mix up allocyclic, we are far in the land. We are talking about lateral accretion of the fluvial system, and we mix that up with the sequence stratigraphic surface. I've seen that many times. You probably have to. That's not good. It's no. Because if you, philosophically, if you look at the ripple cross-lamination itself has a very similarity with the giant delta progradation. So that doesn't mean the ripple is a sequence stratigraphic, element, right? It is not, we know. So in between, you have this allocyclic, autocyclic events. Don't mix them up. And then different scales of sequence stratigraphic, unless it's a composite element or composite surface, we mix it up. And please remember, in the end, I can draw on a seismic line hundreds of colorful lines. That doesn't mean anything. Every line I draw on that section has to have a definition, has to have a meaning. Otherwise, we're going to have this bunch of wool. Otherwise, we can have this bunch of wool. It's your preference. And all this, why am I saying? There was a study done by Westwood Global Energy. It's just last year. So they looked at more than 10 years worth of exploration attempts and stratigraphic trap exploration attempts in 66 basins and 113 different places. See what they find out. So this gray, they are all dry holes. This blue, they are non-commercial. These red ones are commercial. So see, the more than 50% here is, the 70% is dry hole. And if you read this paper, the link is here, you'll see most of these failures are from the lack of subsurface understanding. So it comes onto us. If we fail, it's our problem if we don't try our best. So that's why, be very careful. Don't apply without enough experience and enough knowledge. Otherwise, you may end up doing this. And here is coming back to why. It's a lot of work, actually. The integration of, I don't want to satisfy and end my stratigraphic framework and exploration based on one simple cross line, a well section, or a 2D seismic line. That's not right. You have to understand this whole system in a 3D. It's a lot of work, but the reward is very, very good. All these are stratigraphic. I'm not going to go through them, but some of them, Bengal Basin has seen a lot of them. You have Paleo Hill, we talked about. Oh, by the way, in the Insights Valley field, the Martfield channel, they are very strong. They provide you very strong seismic amplitude. Don't fall for that. That's a Martfield channel. And the contrast with the sand would give you a very strong reflector, but that doesn't mean it's gas there, okay? So you understand it properly. And so these are all the truncation, top set, top cut, and this wave cut terraces. It's a very fantastic stratigraphic trap, and we have abundant here in Western Canadian Sedimentary Basin. So there are all different types of traps you can find, but you have to look for them. It's not like the structural anticlinal trap, but it's a lot of fun. If you do it, you can find a lot of stratigraphic traps. If you remember that curve, nearly 50% of the recent discoveries are from the stratigraphic traps. So in the end, I just want to say, if we can do it right, the reward is great. And I hope we do it right. We take our time, we learn it properly, and we gain enough experience, and then we do it. That's all I had. Thank you. And the next part would be focusing on Bengal Basin by our dear Lodi Bhai. Thank you very much for your time.
Thank you very much. Before deliberation of Mr. Lodi, I request Mr. Aziz to show the photographs of Mr. Dr. Habibur Rahman. Many of us is not aware and known to him. So for 1 minute, he will show Mr. Habibur Rahman's photograph. Then Mr. Lodi will deliver his speech. Okay, thank you. Mr. Lodi, please.
Jashim, introduce Lodi a little bit. Again.
Mr. Lodi is, joined Petrobangla, and after that he worked so many international oil companies around the world, and he worked in Care Energy PLC, after Shell Oil there, and after that he worked for an I think Singapore based company. After that he worked in Petrobangla as a consultant. Now he's a freelancer consultant in exploration geology. Mr. Lodi, if there remains any gap, please fill on yourself, please. Mr. Lodi, please start.
Thank you very much, Joshim Bhai, for introducing me. Assalamu alaikum to the audience. And
Lodi sir, please can you turn on your camera, please?
I turned it off. Sorry. Yeah. Start video.
Thank you.
Thank you very much. I'd like to start by sharing my screen. Is my screen showing now?
Yes.
Okay. All right. Mr. Abu Yusuf has already presented the core concepts and principles of sequence stratigraphy and the methodology that we should be following and what we should not be following. I'll describe or touch upon the some examples from the Bengal Basin of how sequence stratigraphy can be applied and how we can reap the results through its proper application in the Bengal Basin, especially for petroleum exploration and development. My topic will be in three items. So one is I'll try to describe the traditional stratigraphic schemes that we use in Bengal Basin and what are the problems with those traditional stratigraphic schemes. And then I'll talk about the sequence stratigraphic framework in a regional context. And I'll talk about the high resolution sequence stratigraphy that can be applied and applies to the prospect and reservoir characterization and delineation. I'll cite some examples from the Bengal Basin. The traditional sequence stratigraphic schemes of the Bengal Basin can be classified or grouped in two main categories. One that are based on the work of Evans. For example, the outcrop studies of the Eastern Fold Belt from Surma Basin to the Chittagong Hill Tracts. The outcrops that we see by our eyes are the studies are mainly based on Evans' 1932 scheme, and that is done in Upper Assam area. And the other stratigraphic schemes that we see traditionally in our literature and practice are the subsurface stratigraphy that are generated using well logs and seismic in the Eastern Fold Belt area mainly, are based on the work of Assam stratigraphy. And the other category of lithostratigraphy that we see in our literature and practice are the regional seismic stratigraphy that are mainly focuses on the western part of the area of the Bengal Basin. And the other one is the seismic well-based subcrop stratigraphy that are generated based on the wells that are drilled in this western part of the Bengal Basin, mainly in the shelf and the slope or some part of the basin. Here are some examples of how Evans' 1932's work is still being used in practiced in Bengal Basin. Even in 1986, Kingston's stratigraphy mimics Evans' stratigraphy. Here is another example of alternative approaches, because some of the researchers and workers don't like to follow the traditional Evans stratigraphic scheme, so they come up with a different way of organizing the sequences in a stratigraphic succession. Like this is an example from Professor Dr. Alum and his student Doni, who worked extensively in Chittagong Hill Tracts, who suggested that an alternative nomenclature and stratigraphy scheme should be adopted for the Chittagong Hill Tracts areas where they worked in 2003. Here is an example of seismic well-based stratigraphy done by Kurel and Dr. Shamsuddin of Chevron in 2002 and published in APG. That is a departure from the Evans scheme, and they tried to show the prograding nature of some of the formations, both on western shelf and in the eastern part of the Bengal Basin. So these are the schemes that are widely used and is practiced in Bengal Basin, and this is I like most of the traditional schemes that are available. This is by Dr. Reimann, 1993, who worked in the German Geological Advisory Group with Dr. Leeds as well. And he published a book in 93. This is from his book. This is one of the best, to my view, one of the best depiction of the subsurface stratigraphy that shows the gaps, hiatuses, like this one. This is the progression, Oligocene progression. There is no sediment here in the western foreland shelf, and the unconformity is shown at the top between Oligocene and Miocene. So this is one of the, to my view, best representation of the subsurface with facies and lithology in a temporal and spatial distribution. So the dilemma that we have in the lithochronostratigraphy can be grouped in two key points that is pointed out by Professor Dr. Badrul Imam. He is going to present a paper in the centennial publication of Dhaka University. I'm one of his co-authors. So with his permission, I borrowed his comment, is that basin-wide correlation of the lithostratigraphic units are loose and vague. This is his observation and our view as well, as a member of the Bangladesh Stratigraphic Study Group. Definitions and subdivisions of the measured units are ambiguous and are not lithologically discrete and diagnostic. To talk about these things, we all agree, or generally agree, those who are practicing stratigraphy and in the Bengal Basin, agree that the traditional lithostratigraphy units, the correlation, long distance correlation is very difficult and loose and vague. And we also understand and agree there is no good reason for making the divisions and subdivisions of the units like Bhuban, Bokabil, and the Surban group and their members. And we do it just for the sake of doing it. There is no lithologically discrete and diagnostic properties that we can cite for each of these, although there are some definitions for Tipan sandstone and Bokabil sandstone, but their lateral variations are not captured on those things. This is first pointed out, this problem is first pointed out by Braunschweiler in 1980, and he published a paper in APG showing the real problem of our traditional stratigraphy, that we consider them as a layer cake model, and we believe that traditionally that formations like Tipam, Bokabil, and Bhuban or Beryl formations are arranged in a layer cake fashion from northwest to southeast. But he showed that they should actually be cutting the timelines. Like this is the top lithological boundary, which is cutting the timeline, like here in the Beryl formation, top of Beryl, a lithological boundary is cutting through the Oligocene Miocene boundary. So Beryl formation in the northwest, in Kachar Hill area in Assam, is Oligocene, but they can be as young as Pliocene in Sitaikun-Kaptai area, or Lake Miocene in the southern part, like Bhuban. These are all time transgressive units, as in the case where the sediments are deposited in a overlapping basin fill sequence, as is shown here. The red lines are the lithological boundaries, and these are the chronostratigraphic boundaries, the geological time boundaries. This is top Miocene and this is top Oligocene. And Bhuban, for example, Bhuban formation in Nahurkotia in Upper Assam can be as old as Oligocene, whereas in Titash area they can be as young as early Miocene, and in the southern part, in Bengal Basin near the shoreline, they can be as young as Pliocene. So these phenomena of time transgressive units has to be taken into consideration when we talk about the stratigraphy of the Bengal Basin. The traditional stratigraphy fails to capture or address these problems and issues. So with the Tikam sandstone, they can be old as Oligocene in Assam and can be as young as recent in the southern part. Considering these problems, while the German Geological Advisory Group was advising Petrobangla in oil exploration, they had some problem with age dating of the source rock. So they found that there is a serious problem with the traditional stratigraphy. So they acquired a huge grid of seismic data all over Bangladesh. As you can see, here's the map. Is not very legible. Dr. Lee's, this is Dr. Lee's from Dr. Lee's paper of 1982. It's a famous paper that first pointed out this problem and demonstrated that with a number of regional transects using the seismic data that they acquired all over Bangladesh, that the formations or the sequences are way younger than what is traditionally believed. Dr. Lees and his team claimed in their paper that none of the wells drilled in the Bengal Ford has ever reached Miocene. Around, say, 4,000 meter deep wells are all terminated in Pliocene, towards the base of Pliocene, not in Miocene. This is a big shock to the traditional practitioners of stratigraphy. This is an example from SALT, who published a paper in 1986 in a PG that's in CPEX, I think, that uses a data set from the northwestern part of Bangladesh, where on ODA project acquired a number of closed seismic lines in Jashore and Pushti area. This is a regional transect from his paper that's showing the stratigraphy that SALT considers appropriate for that part of the basin. This is the hinge zone, this is the shelf part, and this is the basinal part. This is the horizon 84009. And he identified a number of sequences, and based on his interpretation of seismic vectors and the methodology. And there is this is an example from Linz's 1991 paper. He also used the same database of ODA, and his classification of the sequences are slightly different from that of SALT. But these are all based on seismic stratigraphic methodology. So these are examples. The reason I'm showing these examples is that besides the traditional stratigraphy that we see in the eastern part for the stratigraphy of the eastern part of the Bengal Basin, like in the Surma Basin and Chittagong area, or the Hatia area of the Bengal Basin, there are alternative seismic stratigraphic schemes of the subsurface based on seismic stratigraphic methodology. But we need to think about a few points about the stratigraphic schemes, alternative schemes that SALT, Dr. Lees, and Linz used. Is that this is all these interpretations are based on the seismic stratigraphic methodology that is published by Exxon scientist group led by Vail in 1977. There is a famous publication of APG. And in that paper, the authors claim that the seismic sequences are defined based on seismic reflection patterns and seismic properties. I repeat again, seismic reflection patterns and seismic properties that are believed to have been produced as a result of the geostatic sea level changes and the generated, that's Exxon scientist Dr. Bela Liu Huck generated a sea level curve, global sea level curve in 1988, which control, they believe control are responsible for the seismic sequences, patterns of the seismic sequences and the properties of the seismic sequences. They also assume that the sequence bounding unconformities are found at a certain sea level position. This is a critical thing that we need to understand about the seismic stratigraphy because they have a global sea level curve, and they believe that the sequence boundaries, the unconformities, are produced at a certain point in the sea level curve that Huck produced, and that has a geological time tag, and they are globally synchronous. This is one of the founding assumption of the seismic stratigraphy. Another assumption is that the seismic reflections represent sequence bounding unconformities are represented by discrete geological times reference to the geostatic sea level event. These founding assumptions of the seismic stratigraphic methodology have been questioned by the leading authorities of sequence stratigraphy, like Andrew Mayall, Octavian Catiniano, Galloway, you name it, all the pioneers of sequence stratigraphic authors have questioned all these bounding assumptions of seismic stratigraphy. They believe that these are not true. This is an example of the Vail, from Vail's paper of how sequences can be identified in seismic sequence stratigraphic methodology. This is what is widely practiced in the oil industry, and they become a standard methodology at some point. How the different system stress and the sequence bounding surfaces can be identified, all based on the sea level curve. And the sea level curve is globally synchronous, and they have a discrete geological time. So if you follow this one, you don't need biostratigraphy, you don't need lithostratigraphy, nothing. You have the sea level curve, you just match it with your data set, and that's it. You're done. It's fun. So this is question because sea level curve is not only the controlling controlling mechanism for producing the sequences that we see in our subsurface. There are other control mechanisms that Abu Yusuf already pointed out: the sediment supply, the accommodation and sediment supply, which has underlying a number of other control mechanisms or processes that are involved in creating the sequences. So sea level alone is not the only control mechanism. This is the sea level curve, which is used by Salt in 1986 to produce the sequence stratigraphy of the Western Shelf. Now, these are the, there are at least two other sequence stratigraphy based on seismic stratigraphy. I can cite example from his published by Sikdar and Hussain in 2002 GSA, and that shows that even within the same group, cairn and shell had different sequence boundaries for their mega sequences, and this is compared against the traditional stratigraphy that we used based on the events. I'm not going through the details of how these are generated or developed. On the right side, it is the Shell's Shell Bangladesh's way of describing the sequence stratigraphy. So these are available for us to work on exploration. This is the cairn's way of defining and describing sequence stratigraphy. But when they generated the mega sequences, those are based on the seismic stratigraphic methodology. But when they generated the prospect and reservoir level sequences, the higher frequency sequences, they followed the stratal terminations and stratal geometry, which is more acceptable. So this is an example of cairn's standard stratigraphic column for the Hathia trough, and this is an example on the right side of the Shell's modification of the stratigraphic column for the Hathia trough. So we have a number of mega sequence and sequence stratigraphic schemes available, but we need to understand what are their weaknesses. Like in Cairn's mega sequence framework, lateral variation of seismic facies characteristics of facies belts within a mega sequence could not be addressed. Like they describe in Hathia trough the characteristics of 3 mega sequence they in their scheme, and they cannot be correlated in the northern part of the basin. So it is a kind of local stratigraphic scheme, mega sequence scheme that we can see that is it can only be applied to the Hathia trough, and up to the about 5,000 meter below the surface. The definition of Cairn's mega sequences heavily relies on the seismic facies characterization. This suffers from the veil methodology syndrome as well, so it should be used with care. Genesis and ages related to the Huck's eustatic global curve, which is another problem. They derived their ages and causes of the mega sequences to the veil methodology. Again, age of Cairns mega sequence 1 to boundary of middle to late Miocene, as published by Nazman in 2012, was refuted by Dr. Lees, demonstrating that this is probably as young as Pliocene. There is a detailed description of one of Dr. Lees's not published, but internal communication that Cairns boundary of megasequence 1 and 2 are not correct. He gave a number of reasons why that's not correct. Shell's megasequence framework become untenable because of mixing of various sequence interpretation methodology. Like Shell uses Galloway's scheme of flooding surface to flooding surface. At the same time, it uses ExxonMobil's scheme for using the unconformity-bound sequences, and for higher frequency descriptions, they use another methodology. So there was a mix of various methodology in the same scheme. So that's needs to be used with care. Reliance on global eustatic for calibration of ages and events is another problem with the Shell's megasequence scheme. So considering all these problems with the traditional lithostratigraphical scheme and seismic stratigraphy schemes that are used mainly in the Western Shelf areas, and Cairn and Shell's megasequence scheme, we in Bangladesh study group, called, I think I have to go first. We tried to develop an alternative megasequence scheme. I'll describe this using a number of hypothetical cross sections, at least 3 cross sections. A, B, C, D from north to south, A, B from northwest to southeast, from Regression to the Hathia Trough area, and another detailed interpretation XY in XY cross section in the later slides. And this is because we considered the type, setting, and evolution of dynamics of the basin, subsidence rates and tectonics, sediment sources, sedimentation, and preservation, relative sea level changes. These are many some of the many controls that needs to be considered before making an interpretation based on the latest methodology that Abu Yusuf described. This is the XY cross section. If I go back to the previous one, this is this area ODA data set. This is the published data set that I used to make the interpretation. So XY cross sections shows a detailed analysis that Abu Yusuf described, considering the stratal geometry and the stratal termination types, and also the geometry of the shell face progression. So based on these criteria, we developed 4 mega sequence, 3 of which can be described in the western part of the basin, and the other 4 mega sequences can be described or seen in a regional cross section. If I go back to the previous site for location like A, B section from Regression to the Hatia Trough. These are all hypothetical transect because data publication has some restrictions. So I use my experience and from KN and Shell using regional data sets, and I have generated input from my from knowledge and experience from those time. So the mega sequence one is basically a transgressive systems track dominated system where during the early Cenozoic time, the whole sedimentation was backstepping, as mentioned by Abu Yusuf. So this is the main characteristics of megasequence one. The megasequence two is the time when the basin collided with this is in basic margin sitting megasequence one sequence, and following a collision with the Eurasian plate, the Indian plate with the Eurasian plate towards the Oligocene, late Oligocene, the huge amount of sediment is poured into the basin as it was subsiding rapidly, and there was a rapid propagation of the sequences that generated extensive propagating sequences from northwest to the southeast. And this is we classified as megasequence 2, and the megasequence 3 is propagating and aggregating sequence sets. Actually, these are sequence sets dominated by a specific type of systems track that characterizes it, and the shelf age, nature of the shelf age. Details will be published in the paper that we are producing now with Dr. Lees and Professor Bodhrinimam. But due to time constraints, I have to just show that a fold mega sequence scheme can be developed for the whole of the mega basin following the standard methodology that I will described. This is another transect from east to southwest from Sylhet Trough to Hatia Trough. And this is from north to south, northwest to southeast, and that considers the nature of the basin. The northern part is part of the 4D, and the central part has a 4 bulge, and the outer part has a back bulge. So these things has to be considered when we generate the regional megasequence scheme, and this is based on a regional seismic line that's published in Yanin Asman's 2012 paper. So this has strong seismic characteristics as well, seismic references. So I'll not go into details of this because of the time limitations. So what I want to emphasize that we have to have a very well thought megasequence scheme for the basin before we can zoom into a prospect or reservoir, because when we look for stratigraphic trap, we have to have the mega sequences within which these are developed, because each mega sequence will have different characteristics of the minor units or sequences that's developed within them. This is an example of a seismic line from the southern part of the basin, where I try to show that seismic data can be described using the standard methodology to develop models for exploration of stratigraphic depths. Here, this is a transect along the across the depositional tip of a canyon incision or deep incised valley and its fill, and this is a transect along the depositional tip of the same thing. This is an example of the canyon incision, and the model that we can use as a reference is shown here. And this is the log signature, well log signature. If we drill in a canyon field like this, we should get this kind of log stratigraphy, and we can describe different phases based on the model that can be generated from this sequence stratigraphy interpretation following this methodology. There is another example of a canyon and its field and how that can be interpreted in seismic and well data by tying the well to the seismic precisely. So there are some examples in prospect level that can be used. This is an example of a well log that is interpreted based on sequence stratigraphic methodology that Abu Yusuf described. So the methodology for describing seismic data is slightly different from the methodology for describing well logs, but overall principles should remain the same. And if we have a good control on where in the mega sequence these sequences are developed, we can also describe the depositional phases. So the level of details that we need to have in prospect level identification. This is an example of an offset well that can be used for a prospect or a reservoir. In a reservoir context, we can describe sequence stratigraphic sequences and the depositional phases to be characterized and delineate reservoirs in field development. Here is a আমার মনে হয় সময় শেষ হয়ে আসছে. This is the last slide that we need to think that we should have a workflow starting from the sequence stratigraphic interpretation down to the delivery of the results in the form of geological model and description. So it is not just a 2D seismic line. We identify some signatures of a play and describe these as a prospect. To do the proper prospect evaluation or reservoir description, we need to follow a step-by-step methodology that's shown here. Thank you very much for your patience. If we have any questions, we'll take it to the after the during the open discussion. Thank you, Najim Bhai, Jashin Bhai. Over to you.
Thank you, Lodi, for your nice presentation. I think everyone enjoyed your presentation to us in the context of backward basin. Now I'd like to request Mr. Naz Hussain to introduce Mr. Liz, Mr. Abu Chaudhary, Ahadna Chaudhary, and Dr. Bodul Imam. Thank you. All of them, they discuss in this session, and after that there will be a question and answer session. Lot of questions already done by the participants. I think Mr. Yusuf and Mr. Lodi can give the answer of them after the second part. Now I request Mr. Naz Hussain to introduce Mr. Liz, Mr. Abu Chaudhary, and others, please.
I think it was a very good presentation by both speakers. First, I would like to introduce you Mr. Abu Chaudhary, who has done a lot of sequence stratigraphy work back in the good old days, and I don't remember how long ago, but he's retired right now. But he may make some comment on the presentation today. I would request him to come forward, and after that it will be Badrul Imam. Then we will request Dr. Lees because he has done a lot of work in Bangladesh, and after Lees, we'll be requesting Dr. Ahadnath Chaudhary to say something. Abu Chaudhary, please come forward and give us some of your important comments.
And we have Dr. Nasir Azazul Haq from UK. He is the teacher of some of the students here present from Jahangir University. He can also add something. Thank you.
Okay. So here is Abu Chaudhary.
Good morning and good evening to everybody. I don't know over the world. So here, very impressive broad view presentation given by Mr. Dr. Abu Yusuf and Mr. Lodi. Very impressive. So the principles of sequence stratigraphy has been described very nicely, which actually stems from the Exxon group's work mostly. That's Peterville and Postmanier and Meacham's work. So that is quite consistent with what they have been saying. Now, definitely sequence stratigraphy, this principle that helps organizing the depositional systems into a fashion that we can predict. First, to start with the regional context of the geological aspects, and then the depositional systems, and then we go into the reservoir rock and also source rock, and also the trapping rocks. And these are basically what we try to do with sequence stratigraphy. Is the first we look at the regional aspect, basically. The depositional framework by picking the sequence boundary. And then from that point on, then we look at the different system tracks, the low stems and the prograding wedges and the transgressive and high system tracks. And each of them have different characterization of different kind of lithologies. And for going down to the prospect level from there on, then we would like to actually look for the high energy environments for the reservoir rocks, which would be mostly in the lowest system tracks, would be point source and depositional systems. And then we also like to look at the low energy environments, because those would be the finer rocks, and those would be the trapping rocks, or those also would be the source rocks. I would now, one thing Mr. Dr. Abu Yusuf has mentioned, that there's a lot of failures. One thing is the sequence stratigraphy itself is a model like anything else. So we start with a model and then refine that model, and then come to a reasonable geologic interpretation. And in order to refine that, then we need to be integrating first we start the outcrop, and then we go to the seismic and the well log, and we also need to look at the biostratigraphy. Biostratigraphy is actually very key also, because we need to understand the paleodepositional systems. We also need to actually be age dating our geologic sections. So biostratigraphy is very important, that to integrate it. And the well log signatures And the seismic signatures are absolutely also very important. Now, because the well log signatures, when you have, if you want to pick the high energy environments or the low energy environments, then for the high energy environments, normally you'll find a coarsening upward sequence, and for the low energy environments, and finding upward sequence. So those can be characterized from the well log. And actually, Mr. Abdul Lodi has shown a section where on the well log, the different system tracks have been picked. That is actually a beautiful section because he has shown all the system tracks, including sequence boundaries, that how it can be picked from the well log. I've not seen much of seismic section because we always lack data in Bengal Basin or Bangladesh. But seismic signatures are absolutely very important also, because again, if you want to look at the high energy environments, so and the coarse grained rocks, then those on the seismic would show as chaotic events. Now that can be confused with the slumped rocks, but then with experienced eyes, we need to be understanding. We need to be able to delineate the high energy environments on the seismic sections. And then also this prograding wedges of high strengths system tracks, those also can be identified very well in the seismic because they would be shown mostly as a parallel reflectors on the seismic. So any seismic look at, you'll see there's cyclic in the sedimentation that's a reflector on the seismic. You'll see the coarse grained events. You'll see the fine grained events. You'll see the parallel reflectors. You'll see the chaotic reflectors. So those can be identified there. So basically, if you can integrate all this, like seismic and well log and biostratigraphy, biostratigraphy is actually very key in picking the sequence boundaries because normally what happens, also the paleo environments, because what happens is that in the warming climate situations, when the ices are melt, at the time, there is a maximum flooding. And in that time, because of the warm weather, all these bugs, they're very happy, they are living there. And then when these ice are formed again, in another cycle, then the weather is very cold, so they all die, and they're preserved. So if you can pick that boundary and that event, then we can actually pick the sequence boundary from that. So, so the abundance of these nanofossils, I would say, is very important that can be integrated into the sequence stratigraphic framework. If I go back to very old days, the Peter Vale and Posmentier, they were actually picking the sequence boundary on well logs only because they did not have at the time seismic. And what they did is that we actually, I was in that group myself. We formed a group. I was with, so my background, I worked for in Ohio and British Petroleum, and then I went to work for Schlumberger and Western Jaco. So in Schlumberger, Western Jaco, we formed a group with Exxon. And what it did is provided the seismic to Peter Vale and Posmentier and Mitchum. And then what they noticed that they were picking in sequence boundaries on those well logs. However, there's no continuous in profiling of those well logs. So when they put those well logs on the seismic, they had to refine their sequence boundaries that was picked on the well logs based on the seismic. So at the time, we really formed this group, integrated group with the Exxon and Schlumberger, Western Jaco, and we formed this sequence stratigraphy team, and we did significant amount of work And then we also actually picked up Bernie Schaeffer from Shell. He is the biostratigrapher. He's a famous, very well-known biostratigrapher and Bernie Schaeffer. So Bernie Schaeffer, and Pete Vell, and then Weston Jacob, Schlumberger, we formed a team. And we did significant work integrating the well logs and seismic and biostratigraphy. And we did a lot of work together, at least for 5-6 years, and then moving forward and further and further. So it is very important that we integrate all this to mitigate the risks. And then again, we can get bogged down with is it number 3 in a cycle or number 5 cycle or whatever, you know. But then basically, when you get down to business in finding oil and gas, what we need to look, and seismic is definitely very key. We need to look at the seismic and the well logs, that basically the cyclic patterns of the deposition are reflected in there, and then we need to be able to pick all those events, and then pick the boundary, pick the high energy environments, high energy rocks, and pick the low energy rocks. And then from there on, of course, moving further, we also use high-end processing and so on and so forth, and then do further high-end geophysical analysis and time amplitude work, time offset work, and so on and so forth, and characterize the amplitudes, and then just to make sure that we are not mixing the water sand with the gas and so on and so forth. So basically, it's a very nice tool. Start with the regional and the boundaries, and then divide the packages, and from there on, use high-end seismic analysis, look at the amplitudes, and then characterize those amplitudes and calibrate them with the well logs, and then go find oil and gas. So integration, seismic, well log, and biostratigraphy, and get reasonable results. So again, beautiful presentation by Dr. Abu Yusuf and Lodi. They definitely have shown a lot of data, a lot of in-regional data. We now need to, this practicing this is very important. Anything is experience. So all our geology phases need to be, practicing and finding the geology. We find geology in outcrops, we need to find geology on our seismic and our well logs, identify them and find reservoir rocks, use high-end geophysics and find oil and gas. That's all I need to say. Thank you.
Thank you, Abu Chaudhary, for very, very nice, excellent comment and information. Now, Jashim will continue with the next speaker, next person who is Badrul Imam. Go ahead, Jashim.
Thank you, Mr. Naz Hussain. Before that, I now like to request the speakers, Mr. Lodi and Mr. Abu Yusuf. There remains a lot of questions in chat box, and few for Mr. Lodi and few for Mr. Abu Chaudhary. And they should prepare for that to give the answers of that questions during question and answer session. Now, I like to request Mr. Badrul Imam to, I think, for his, make the comments regarding the deliberation of this technical session.
Thank you very much, Jashim, Mr. Jashim, for giving me the first of all, I like to thank Mr. Dr. Abu Yusuf and Mr. Abid Lovely for their excellent presentation. Both of them are very well versed in sequence stratigraphy, I understand, and I know. And in particular, I'm very glad to have Dr. Lees in this session, because Dr. Lees is one of the very experienced person who is actively, till date, working on sequence stratigraphy and in stratigraphy in general. And actually, he's working with a group of Bangladeshi geologists, and we are trying to establish a renewed or updated stratigraphic succession of Bangladesh. And having said that, I will just throw some comment on the presentation of the stratigraphy of Bangladesh as its status is at present. Now, talking about stratigraphy of Bangladesh, the first thing one notices that the Bangladeshi stratigraphy suffers from too much generalization, as too much simplification. So as early as 1980, Brunschweiler pointed this out, that this generalization and oversimplification is inundated in Bangladesh stratigraphy, because the basin, as we have seen from the presentation, are very complex. There's no scope of simplifying it and adopting a layer cake geology or layer cake stratigraphy. But unfortunately, the Bangladeshi stratigraphy till date is continuing to adopt this layer cake geology, which was initially adopted or established by Evans in 1932. And Evans stratigraphy, subdivisions of litho units like Bhuban and Bokabil, these are very, very commonly used in Bangladesh. Yet, despite the fact that that is actually not possible, in two counts. Firstly, the lithology of Bhuban and Bokabil is not consistent. I mean, it is not possible for a mega delta to remain lithologically same over a long distance. So the correlation from Assam to southern Bangladesh, it is untenable. So that is not really possible. But the first point is that we are actually doing this thing in spite of knowing that and understanding that this is a very difficult and complex thing. Secondly, about the age. Now, yet again, Evans' age of his litho units has been copied into the Bengal Basin. That is another point which is very wrong. And at this point, I can tell that one of the very, very crucial question and fundamental question, groundbreaking question, has been raised by Dr. Lees. Not now, but even as back as 1982, when he wrote this paper in which he suspected or questioned whether any wells drilled or any sediments older than Pliocene has been encountered or drilled in Bangladesh. That means if we translate into geology, that means the Bhuban and Bokabil, which we are practicingly telling that these are lower Miocene and upper Miocene, these are not at all Miocene. So the question is whether the age of those rocks are correct. There are significant amount of data and analysis which says that this need to be changed. And I'm happy that Dr. Lee and a group of Bangladeshi geologists, of course, under the guidance of Dr. Lee, has been trying for about 3 years now to revise these aspects and rethinking these aspects. And hopefully they will come up with a revised stratigraphy. I hope that Dr. Lee will throw some points or comments on this. And we are actually welcoming anybody who has an interest in stratigraphy and to do this job. Now, to sum up and end my comment, I very much like to appreciate Dr. Abu Yusuf and Abid Lodi for their work and what they have shown. They have shown a lot of data, and the time that is given to them is probably less than what they would have love to have. And also for us, we probably go back to those data from the records and listen to them once again, or maybe twice, to fully understand and appreciate their contents. And with this, I thank you very much for giving me the opportunity to talk. Thank you.
Thank you, Mr. Budrul Imam. Definitely, everyone is waiting eagerly for Dr. Lee's comments. I think Mr. Lodi referred a lot of, quite 2 times for Mr. Lee's about Dr. Lee's works. And I think we are also waiting for his comment. Before that, here is Mr. Nasir Azul Haq. Nasir Azul, before delivering Mr. Lee's, I request to say something, Mr. Nasir Azul Haq.
Thank you, Joshim Bhai. I'm really quite happy to be a part of this participant of this presentation. Dr. Abu Yusuf presented the concept of sequence stratigraphy quite well, and Abid Lodi Bhai presented the Bangladeshi part of it quite well. There is no doubt that there is a scarcity of data. There's no doubt that we are not able to build a proper stratigraphy of the country, and also the 3D lateral variations of the facies and the strata across the country because of lack of data. But it doesn't mean that we should simply just keep idle and do nothing about it. I was really pleased to see to learn that Dr. Lee's under his leadership and Professor Dr. Budrul Imam and Lodi Bhai and others are looking at getting something to publish in the near future. And he has shown some of those figures in his presentation as well today, which was really impressive. I think what we need to do is try and he clearly said that these are hypothetical figures, the mega sequences he presented. And I think we need to be really make some breakthroughs. And even if this is in the long term, even if this is disproved, we need to do something about it. We need to be bold enough to go out and say, guys, this is what we want to present. This is what the hypothesis we are making, and let's work on it. Because if we don't go out bold enough and propose something, nobody will bother doing anything. And then even if it is disproved, say 5 years from now or 10 years from now, it doesn't matter, because we have made some progress, something has been disproved, and a truth has been discovered. So what we need, and I saw in Abid Lodi Bhai's presentation, in one corner I saw a block diagram, and that actually interests me most. Apart from the 2D figures, I'm very keen on building up a block diagram for the Bengal Basin, where you have the distribution of various elements in there, even if it's hypothetical, channels, levees, floodplains. How big was this deltaic channel? How many branches did it have? Those kind of things. Let's based on whatever data. I know data is extremely scarce. It is the number of drills we have in the Bengal Basin, probably one of the lowest in the whole world, given such a big basin in here. So one thing I'm interested about block diagrams, 3D block diagrams, and I'm also interested in comparing the exposed stratigraphy in the eastern foldal belt, because that's the only place where you can compare. I know it is no doubt lateral variation is huge. No doubt there is lateral variation. Anyone who understands the element distribution, the geomorphology, how the river systems work, how the delta system works, everybody will clearly say the lateral variation within few kilometers can be there, and they are there. But the exposed part in the eastern foldal belt is the only tools where we can make some reasonable comparison with what we have in the subsurface in the deeper part of the Bengal Basin. So let's try and compare what we have in the exposed sequences. The publication by Goni and Alum on the alternative study they proposed, I think that could be a means to compare to some extent. And any work we do, I know in the various departments, geology departments, our students go out and do the field mapping, do the MSc thesis, they publish things. Let us get all of those together and try to compare what we have with your seismic stratigraphy in the deeper part of the Bengal Basin. So my point is very simple, and I just make 2 points. One, let's work together in building a 3D block diagram for the Bengal Basin. It could be rubbish in the 5 years' time, but let's go out and do it, because unless we do something about it, we'll be stagnant in one place. Secondly, let's compare the exposed sequences in the Bengal, in the eastern folded belt, and compare them with this seismic stratigraphy we are getting from the seismic data. These are the 2 basic points I want to make. And once again, I thank Dr. Abu Yusuf for his nice presentation, and Abid Lodibhai for his presentation, and obviously it intrigued me quite a lot through this presentation. Thank you very much.
Thank you, Mr. Nasir Ijaz. Now I'd like to request if here is Mr. Jahangir Kabir, who worked a lot of work with Dr. Lees, and you have seen some papers written by both of them. Dr. Jahangir, no, I think, sorry, Mr. Jahangir Kabir. Jahangir Kabir bhai asen, please.
I don't see.
উনি আছেন, আমি যোগাযোগ করতেছি নেক্সট।
I don't see.
I have not seen him.
Okay, go ahead with Dr. Lees.
Yeah, after Lees, I think our second session will be conducted and will be started by Dr. Ahadna Chaudhary. I think this session will be concluded by Dr. Lees. Mr. Lees, please, please.
Yes, I'm here.
Comment, please.
I'm here. Yes, thank you very much. I'm very happy to have been invited to take part in this talk today, because it's for me like a little bit coming back to Bangladesh again, where I lived and worked so many years. I like your country very much, and I hope one day I might see it also again. Yes, I came to Bangladesh in 1977 as a member of the German Geological Advisory Group. And at this time, it was the task for us to assess the hydrocarbon potential of the country, also with regard to possible oil prospects. Oil had at this time a very important factor still, because you had to import all your oil reserves, and we were eager to find out whether there are chances. And as a key to get an understanding of the subsurface geology, we had a support by our German seismic group, Prakla Seismos. They came partly with 2 crews in the country and shot for the first time digital multifold, 12-fold seismic. This was very new at this time, and compared with the older analog single-fold seismic, it was a very good jump in quality and good for seismic interpretation. We started our work in the shelf area according to the saying from source to sink, and not the vice versa way. And the first line which we shot was the Prakla line PK1 and PK1 extension. PK1 started somewhere where presently the Singra well is located, and then crossing the hinge zone, the 4 deep, down into the upper delta plain, close to the wells Muladi 1 and Muladi 2. This was one big regional line, and it gave a lot to interpret in this line. What we did is to find sequence boundaries. We wanted to get an idea of the subsurface set up in structures, to the setup of structures, and for this one was this line very good shape. And later we included the basin as well, not only in the direction to the down dip, to the delta plane, but also deeper into the central part of the basin. And then another area became investigated by Patla Seismos. This was the Soma Basin. And the idea came up to set a regional seismic network to understand the subsurface in a better way. And for this purpose, it was important to have a basic seismic grid which could be dated. This was one of the most important issues for us. The seismic interpretation not alone, but also the tie-in of age information. And the big advantage was that we had a very close contact to colleagues from ONGC in Kolkata, and also from the Wadia Institute in Dehradun. And we had many exchanges among each other, and we could easily tie in the seismic lines from Bangladesh across the border into the seismic grid of West Bengal. When we started our first line, then had already at this time, West Bengal covered the whole shelf area with 20,000 line kilometer of reflection seismic. They had refraction seismic, and about 200 wells were also drilled. And this was a big advantage for us because we could utilize their data and correlate their information with our information across the border in Bangladesh, so that we could tie in the first age informations in our Prata seismic lines. And we could not understand in the beginning how the shelf area, our focus working area, was also taken into the consideration to speak there in stratigraphic terms also Uban and Bokabil. And these two stratigraphic names became a kind of synonym for stratigraphic age at all. Everything was Uban and Bokabil, with the term of stratigraphic term in time, lower Miocene and upper Miocene. And this was for us a very crucial point to go deeper into the issue. And more and more information came, and the shelf line PK1 and PK1 extension got the first information, stratigraphic information from West Bengal. So we tied their geological information into the Pratla line as well. And there was one big unconformity or a boundary, stratigraphic boundary, which we called in this time R3, reflector R3. And in later time, when the wells, Singra was drilled, Singra became the key well for the stratigraphic ties, which were first related to West Bengal, and later it became a very strong scientific dispute of this reflector R3, a major unconformity is, or nur a transition from middle Miocene to late Miocene. And when we compared, this was the understanding of Dr. Reimann. He was in our group a palynologist, and he investigated core samples from the Singer well. And his investigation showed very clearly sediments from the Eocene at the depths to the Oligocene, to the lower Miocene, also to the middle Miocene. And at the Singer well, at about 1,300 meter depths, there was a transition, what Dr. Reimann said, a transition from middle Miocene to upper Miocene. And this was in strong conflict with the evidences from West Bengal. They had also an unconformity, but on top, above the unconformity, was Pliocene and Pleistocene. And so we had a very strong contradiction in the key well, the Singer well. And this conflict is still going on. Dr. Reimann was not in the position to respect also the other issue, which we had in the paper also documented from 82. We assumed this one, but this is until now a very scientific discussion which has to be solved, but I think in the first line. And all the evidences speak in favor that there is middle Miocene. On top of the middle Miocene is Pliocene and Pleistocene. And if we project this one, this unconformity R3 can be deeply followed into the basin. And the question came, is there Miocene at all in the basin, or is it a very young basin which has received a huge load of sediment together with rapid downward movements of the very deeper crust due to tectonic forces. And this point is still not directly contradicted. It is still a point where we all scientists or paleontologists or seismic interpreters, not so much yet now in the way to find out suitable traps, but more the stratigraphic age, to give Bangladesh a new stratigraphic frame and to overwork or to deal strongly with the stratigraphic age of the Bengal Basin. This is one of my heartiest topics, and I hope that this topic might also be solved one day confidently and for everybody accepted. But as long as this question is still open, we have to think about it carefully, to exchange our views, to look into the literature, because not only in West Bengal and in Bangladesh is the middle Miocene overlain from very young sediments. This this unconformity can be traced down to the Godavari Basin, and there is a very big gap between the middle Miocene and also Pleistocene. So something must have happened after the middle Miocene, which have completely changed the tectonic development, the stratigraphic development. And what I very strongly think is that the Bengal Basin is a very young, strong depression, or is a basin which has been developed at this time from between the Middle Miocene and the Pleistocene, especially in Pliocene and Pleistocene, by very rapid movements due to plate tectonic events. I would like to stop here and to have maybe some points of discussion. I also want to ask Abid Lodi, his colored sequences. He could show whether these are hypothetic sequences or whether they are also controlled by well control, where a confident stratigraphic age could be copied into his synthetic sections. I thank you very much for listening. Unfortunately, I have not prepared for this meeting. It came to me only day before yesterday, the invitation, so that I could not show any sections, but maybe at a later time we can arrange this as well. But please keep in mind that there is still a big job to do to set up a basic stratigraphic framework for Bangladesh. Thank you very much for your time.
Thank you. Thank you, Dr. Lees.
Thank you, Dr. Lees. I think we are thinking, we'll provide a full session for you our next time. I think then you will deliver your all the issues regarding Bangladesh.
Yeah.
And now I like to thank you. I like to read an appreciation from Dr. Mohammad Hussain Tipu. Dr. Mohammad Hussain Tipu, please read your appreciation for Dr. Jurgen Lees. Tipu, please.
Yes, Joshim Bhai. The reason why I mentioned here, actually, we know Dr. Lees by his name and work, and as he clearly stated that he has been working in this basin since 1977. And obviously, under the guidance of Dr. Lees, we got a good number of petroleum geologists who are also doing great, not only in Bangladesh, across the globe. So, and from that context, I would believe that from the whole geologist or geoscientist community of Bangladesh working across the globe, we should appreciate the contribution what Dr. Lees has made to the petroleum prospects of the country and what he is still doing at this age. So we really wish his long life in good health, and we would like to see his active participation in the upcoming seminars of this forum also, especially on petroleum issues. Thank you, Dr. Lees, and thank you all.
Thank you, Maharaj. Thank you.
Thank you.
Thank you, Mr. Tipu, Mohammad Hussain Tipu. Before going the next session, I like to, call Mr. Mullah Amjad Hossain. He is the editor of Energy and Energy
And Power.
Yes, please. And he used to present in our every session. If he is present, please say something. Mr. Mullah Amjad Hossain.
Mullah left, I guess.
Okay. Now I like to request Mr. Ahadna Chaudhary, starting of our second session, please. Mr. Ahadna Chaudhary.
I don't see a hat.
No, he was, a moment ago, he was in. Mr. Ahadno Chaudhary, please.
I think he's left. He's not here.
Oh, maybe. Now I request our two speakers to give the answers of the our participants. They will be very happy to, I think, to get the answers from my two selves. First, I think I invite Mr. Abu Yusuf. This is the academic questions mostly. Okay, please.
Okay, actually, I have replied to all of the questions via text directly to the person who asked the question. So it's done.
A lot of question in chat box. So I think you can
Yeah,
get.
I kept addressing them as we went through the presentations.
Okay. So we can open the floor. Anybody has any questions?
Yes, I think there were some questions from for Mr. Lodi. I think Mr. Lodi, you have seen, and you can see the answers.
Yeah, I have a few questions from the audience. The first question that is asked by Mr. Motin of BAPEX. The question is, in seismic sequence interpretation, what does seismic reflector signify? Is it a geological timeline or a contrast between the two lithologies? I think we have two pioneers here, Dr. Abu Yusuf and Dr. Abu Chaudhary, two pioneers in seismic sequence and sequence stratigraphy who work with the top ranking sequence stratigraphers of the world. But this is a very valid question when seismic interpreters or geologists try to interpret horizons, seismic horizons in the seismic data set. They pick some strong amplitude and start picking it without majority of the young fellows without giving proper geological context to it. So sometimes they consider whether it's a geological timeline or a contrast between the two lithologies. Actually, in seismic stratigraphy, the seismic reflectors are considered as chronostratigraphic surfaces, so they represent geological timeline. At the same time, I have very limited knowledge in geophysics. What I learned so far is that the seismic reflectors are coming from the acoustic impedance of the two contrasting lithologies. So which one is true? This is also my question. I sometimes get confused whether it's a geological timeline or it's a lithological boundary. In prograding sequences, off-flipping sequences, geological timeline tend to cross the lithological boundaries, which is a common phenomenon. So I asked myself these questions and tried to find an answer, looked at the literature. What I came across is that the seismic reflectors that represent geological timeline actually come from a very, probably, this is my view, my way of thinking is probably coming from a different attribute in the geological sequences, which are associated with what's that called? Some post-depositional diagenetic changes in the geological formations. There is a bunch of literature on this, on sequence stratigraphy of the diagenetic surfaces. So I think this is neither. This is definitely in some cases the seismic reflectors come from the contrasting lithologies if appropriate conditions are fulfilled that generates acoustic impedance. But in regional scale, they definitely represent geological timeline. But a good understanding of geology and geophysics will give the interpreter an age to make a good judgment on what they're interpreting. The second question was from Dr. Aminul Islam.
Sorry, Lodhi, if I may
Yes.
add to your response, I actually directly written to Mr. Motin there. So yeah, I agree what Lodhi just said, but in short, in very briefly and short, what it is, seismic reflectors can pick up a lot of contrast, and it can be ranging from diagenetic surface, especially in carbonates, and even in clastics, it can pick up the diagenetic surface, but at the same time, it can also pick up subtle lithological changes. And I've seen a whole range of things that seismic reflectors can pick, and also some fake ones too. So, say like Abu Chaudhary Bhai was mentioning, integration is very powerful to understand the reflectivity of seismic or anything, to be honest, in the basin. Thank you.
The second question was from Dr. Aminul Islam from, I think, Brunei Dar es Salaam University. He asked me a question to display the arbitrary seismic section to have a feeling of the deposition of packages. I mentioned in my presentation that these are arbitrary regional transects, which will be published in a paper from Dhaka University, 100 years celebration. The arbitrary seismic sections are based on my experience of Bengal Basin and some published seismic sections. Dr. Lees also asked me the question, a similar question of whether these arbitrary regional transects are tied to the world, if I understood correctly. No, the answer is no. These are, and he also asked me whether where the edges are coming from of the boundaries of the mega sequences. The answer is that to show that, I'll probably have to, sorry if I'm taking a little long, I have to show another slide which will be part of the presentation, part of the paper, which is shown here. I don't know whether it has gone to that. Let me see if I have. Oh, this is difficult. I think I have done a chronostratigraphic. Let me see if I can display that. No, it is not there yet. I don't know. I can't display that section. There is a chronostratigraphic display of the first transect that I showed in my, which is transformed into Wheeler domain and tied to the stratigraphy of the West Bengal and regional main events that signify geological timelines. So answer is it will be described in the paper, and that will be published. And there was another question. How can I get to the question? Another question from Khalid. He said, from mega sequence framework moving to high resolution sequence, I could not cope up. Yes, it is difficult or a lot of experience is required to understand how high resolution sequence stratigraphy can be interpreted within the mega sequence framework, but it is essential that when we do any higher resolution sequence stratigraphy of a prospect or a reservoir in a field, we should have we need to put it in a mega sequence context. Otherwise, we'll not be able to give it a proper treatment. Another question was from Dr. Azad. He asked me, I looked into the sequence boundary of Cairn drawn from offshore basin. Mapping these events was difficult. Yes, it's true. The mapping of the boundaries of the mega sequences are difficult using the existing framework. That's why we are proposing another one, a modified one or updated one that should enable proper correlation in a regional context. Mapping or correlating higher resolution sequences in a short distance is difficult because of the underlying geology. It changes very rapidly, but a good understanding of the geology and the methodology of sequence stratigraphy can help in minimizing the issues. I think he also asked whether ignophases can be useful. Yes, indeed, ignophases should be integrated in the sequence stratigraphic interpretation, but ignophases has very limited application in the subsurface, especially when we do in seismic resolution. Ignophases is of little or no use. But if we do a sequence stratigraphy in a well, core data, and if we can integrate it with the outcrop surfaces, it can be useful for identifying the sequence boundaries. Thank you, Dr. Azad. I hope I answered the questions, but the time is short to answer or attend to all of the questions. Thank you for your attention. Thank you very much.
Thank you, Lodi. Dr. Azad from Chris Energy, he raised his hand, and also Mr. Khalis. Mr. Azad, please ask your question.
Assalamu alaikum. আমাকে কি শুনতে পাচ্ছেন? Can you hear me?
Yes.
First of all, I thank from core of my heart to Lodi Bhai and also Abu Yusuf Bhai. It was excellent presentation. As being follower of Lodi Bhai, I would say that I'm working in the International Oil Company, so I had the opportunity to look into the seismic boundary, both the shale and Cairn seismic boundary that has been drawn previously. So I tried to map these boundaries in the seismics, and we do have really good control in the offshore that we all know. For the onshore, we do have difficulties of getting the data, but offshore is quite good. And obviously there are 2D data. So what I wanted to do is to look into the main feeding system. The objective of that was to map the channel levee complexes. For instance, the present day setting that we can see, if we map the Pleistocene sequence boundary, it is quite easy in the offshore. But when we are going to this mid-Miocene or upper Miocene, the channel bifurcations or these reflectors are so ambiguous and so crumpled and so broken. So it was very difficult to map. So my questions to Lodi Bhai, that is that possible that we could isolate the feeding channels of each time zones and thus to map the channel levee complexes in different time slices, which is really difficult, I can understand. But that is the challenge, the people that we work in the oil industry, because that actually gives you the sense of identifying your reservoirs and your source and whatever. Thank you.
Well, if I were to answer this question, is that yes, the challenges are there, and especially the incised valleys and distribution is very complex, as you know, especially in the southern part of the Bengal Basin, and also in other places like in the western part. Multiple cut and fill are there, so it's very difficult to isolate each of them separately. It's a big challenge. Lots of 3D seismic can help if we are working on a prospect or field level. I think 3D, if we have 3D seismic data, we should be able to generate stratal slices and can generate the paleogeography map to understand these things. But before that, I think we'll probably need processing of the data to make higher resolution, higher frequency data, so that we can pinpoint those things. But it depends on what resolution or what details is required by an interpretation. So it is challenging, especially in the Bengal Basin where there are multiple cut and fill. But this has prospects. If we can properly make the interpretation, we should be able to find prospects in it. Thank you very much. I hope it answers.
Thanks. Thank you very much.
Okay, our last question made by Mr. Khalid. Is he here? He raised his hand earlier. I don't see him. Khalid, are you here?
জি আমি আছি
Please ask your question, please.
So I didn't want to ask any question. I'm just adding few things that we have to be very clear here, like what Lodhi said about that about the question about sequence boundary and the lithology thing. The thing is seismic reflectors. This is the combination of lithology, pore fluid, and the framework. So it is the combination of everything that called acoustic impedance. So it never shows you the boundary or anything. It's the acoustic impedance. Then how do you get the boundary? You get the boundary when you get all those reflectors, and then you trace those out, and then you see their attitude. Is there like pinching out, or if they're cutting off by another surface, or it is onlapping, offlapping. So that's the way you get boundary, and those boundaries obviously reflects the time. So the seismic reflectors doesn't say you about the time, but they leads you to get the geological time boundary. Then about the mega sequences, I'm happy that Lodhi bhai at last he came back to the 4 mega sequences thing. He had a lot of questions during my presentation, but then he kind of agreed that there are 4 mega sequences. And these 4 mega sequences boundaries are mostly coincide with subaerial and subaqueous unconformity, and that relates to the movement of our plate. That goes way back to the movement of Himalaya. So they coincide with the Himalayan upliftment movements. That's how we get the mega sequence boundaries. Then the question Azad just raised and Lodhi bhai explained is very nicely that we need 3D seismics. At least we need more data, and we need some ground truthing with those oil logs and oil data to map those levees or channels and those things. There was another concern that's saying that the mud fill channel could be really misguiding in sequence stratigraphy, and when the seismic impedance is interpreted, most of the time we see that those channels, if are concave downward or convex upward, that is very important to know about the lithology. And I'm saying again that the seismic never shows you coarse grain or fine grain. That we learn from morphostratigraphic analysis. And when we have morphostratigraphic knowledge, we get that thing. And as Abu Chaudhary bhai, he said a lot of things, and that is very nice for a perfect world when you have lots of data, thousands of oils and seismics data, 3D seismics and biostratigraphy and lithostratigraphy, and you can correlate those oil logs. But where you have nothing, then what do we have? We have to make sure that those are well interpreted like every inch or every every dots of it. Like we have the Bengal Basin in the southwestern part. We have that new hole, and then we need to do that in the Mobar pool oil. We have to analyze all those things to get a clear or a better idea. As Dr. Lees was showing, and he was really keen to explain how those reflectors came in, and I am very happy with it. So when you go up to Godavari Basin, and we can go up to Mahananda Basin too, so there is a gap in that areas, but the interpretation of lithology from upper Oligocene, that means Miocene to Pliocene, there is we do have to distinguish those lithology, and we have to describe those in a proper way. And that's what I can say in my adding point with Lodhibhai. Lodhibhai, thank you for your conceptual sequences for Bengal Basin. I think that is a breakthrough. And what I'm adding here is I thought, like, if you go back like 2003 or so, that Dr. Alam, he had a total volume of sedimentology, Journal of Sedimentology, only on Bengal Basin. So can we do something like that with the seismic stratigraphy or sequence stratigraphy of the Bengal Basin? And I talked preliminary with Professor Badrul Imam. He agreed, and I talked a couple of people too. I talked Lodhibhai a little bit about it too, that if we agreed and we can find some papers, and that would help us to make a full volume of sequence stratigraphy of Bangladesh with any or some reputed journal. And I put forward this idea that can we do it? Professor Lees is here, he can contribute too. Dr. Lees is here, he can contribute too. And I appreciate if Lodhibhai and others, they contribute, and we can head up with the Professor Badrul Imam, sir. Thank you very much.
I just want to add a couple of things following Khalid's comment. Excellent, Khalid. You reached out a lot of different things, but one thing I want to make sure that we don't misunderstand. Yes, on the seismic, the maximum flooding surface, if we cannot see, we shouldn't even do sequence stratigraphy. On the seismic, it is very clear, even on the well logs. So yes, you do see horizons on the seismic, especially the maximum flooding surface, and the others are the stratal relationship. And also in terms of time, these are time regressive or transgressive surfaces we're talking about, because the ocean doesn't flood the entire basin at once. It just doesn't.
Not in a second.
It moves through time. So yes, you will see the seismic, on the seismic horizon, at least the maximum flooding surface, and also in the parasequences, you'll see almost every flooding surfaces. So you do see a lot on the seismic. And in terms of mud-filled channel, I don't want anyone to confuse mud-filled channel with the sequence stratigraphy, because mud-filled channel is a process after the fact. You have insides valley, which is related to your sequence boundary, and that is your sequence boundary, sequence stratigraphic context. Mud-fill is an after fact, and that is a channel fill episode, and that is partly, depends where you are, it could be totally autocyclic, has nothing to do with sequence stratigraphy, okay? I just wanted to clarify these 2 points. Okay, thanks.
If I get a chance to clarify one or two points of Khalid's comment is that the first thing is that the fourfold mega sequence classification that I presented was done a long time ago. Professor Badrul Imam knows about it, Dr. Lees also. We prepared the paper last year. This is number one, before even presentation of your paper. So the second point that you made about publication, like Dr. Alam's publication in 2003 in Sedimentary Geology, yes, it's a good idea. And Professor Badrul was suggesting similar thing long time ago that we should publish in a in a reputed journal. Yes, we will look forward to that. Thank you, Mr. Khalis. Thank you very much.
Mr. Lodi, I have received, I think, a request from one of our participants for you. If you, I think, allow, then I will let him to provide his question, please. Yes.
Yes,
Azad.
yes, please.
Unmute, please. That is muted.
Okay.
Okay.
Now you hear me, right?
Yes.
Well, there is another Azad. I am Mir Karim. First, hello to Dr. Leeds. Glad to see you. I hope you remember me. I would like to visit you soon, and I will be contacting you. And then I'm really amazed by hearing Dr. Yusuf and Lodi, one of my favorite geologists. The presentation they did is really wonderful, and we expected that. We knew that they would be doing like this. But as many of you know, that I had been working for, well, before that, I would say that I wanted to be sedimentologist, but I turned to engineering geologist. I don't know whether it is a success or failure in my life, but I wanted to be sedimentologist, turned to be engineering geologist. But I understand sedimentology because I need to understand for doing, solving the problems of engineering geology. So I need help from everybody in this forum, because I am working very hard for last 4 years. I am studying like a 5-6 grade student on tectonics of Bangladesh and the mechanism of earthquakes and mechanism of tectonic effect on magnitude criteria of earthquake in Bangladesh. And this is my, I don't know what I should say. I am fighting and only lone person. Some friends are helping me. I need your help from receive some of your work, some of your seismic session, some of your seismic profiles, whatever you have in your hand. And I hope you have my email address. Send me. I want to prove that there will be no 9 magnitude earthquake in Bangladesh.
Okay.
Ever.
Yeah.
So please
Azad.
help me. Help me. Okay. That is my question. Okay.
Thank you too much. Is there any response from Mr. Lodi? I think he asked I think he requested all of us. I think we will consider, every geologist will consider, and they have seen your publication and your poster. I think everyone may, I think most of them will respond you soon. I think so. I thank you for your, request. And now I like to, conclude this session by Mr. Naz Hussain.
Well, it is about 10:30 Bangladesh time, and I thank you all very much. And it was a very interesting session today on sequence stratigraphy. We had a lot of input from Dr. Lees and from Abu Chowdhury, and on the presentation that was made by Abu Yusuf and Lodi. And it was a great presentation. I have been away from this, but I still am interested to hear all these things for knowledge base. Thank you all for attending the session. We will see you again next time. Thank you.
Thank you. We can conclude by the permission all of our participants. Thanks again.
Thank you very much.